Okay, in today's video, I'm going to be teaching you about the sixth index law. So our learning intention today is to learn about the sixth index law, and our success criteria is to understand the sixth index law and apply it to questions, use knowledge of bases, powers, and multiplication rules to questions, and be able to input powers in a calculator. So let's have a recap of the fifth index law, which was my previous video. I have rewritten what that law is, just in case you have forgotten, okay? Basically, whatever we have inside of a set of brackets, if that is then raised to a power like so A, B are just variables, and M is a number, let's say, that is to the power of everything inside those brackets. The M gets placed, let's say, on top of each and every variable in the bracket. So you can see that M has been put on top of, let's say, the A, and then on top of the B. Now, what I mean by on top of is the M has been multiplied to the index of A and then to B. Okay, so it has multiplied. Okay, but for now, while you're still learning and becoming familiar, you can just think of on top of, if it makes it easier for you to understand. But what is happening is this external power is being multiplied to the inside of everything of the bracket. And remember, if there's no number on something, or to the power of, there's an imaginary 1. Okay? When there's no gaps between something, there's an imaginary time sign. So that's where this comes from. So let's practice with an example. Let's say we have, well, let's just use this one as an example. Let's do A, B to the power of 5, let's say. So how would I do this? There's an imaginary 1 on top of my A and an imaginary 1 on top of my B. And again, what I mean by on top of is to the power of. Okay. Now all we need to do is take this 5 and multiply here and multiply there. So my answer is 1 times 5, 1 times 5. Okay, so we're multiplying. Now I can go ahead and get answers for those. So it's A, 5 times B, 5, or to the power of. And then to make this look neater, we can just get rid of the times sign and leave it as A to the power of 5, B to the power of 5. Okay, now let's get into the sixth index law. Just leave it like this for a second in case you want to pause and write that in your book. Okay, so our sixth index law, the final one that I'm going to introduce to you guys. When we have a fraction, let's say, or a variable divided by another variable, okay, like so. So here is what we would call the division part, all right? So remember that this is the exact same as this. Okay, we learnt that from the second index law. This, written like this, is the exact same as that, okay? Now, the fourth and fifth index laws do not involve situations like this. The sixth index law is the only one that looks like so, or set out like this, but it's the exact same thing. All we're doing now is the M is being multiplied to here, and the M is being multiplied to there. Okay, and that's how we get a to the power of m and b to the power of m. So everything inside the brackets is being put to the power of m, okay? Everything inside the brackets. That is why the m has been multiplied to the top over here and the m has been multiplied to the top over there. And we get a to the power of m divided by b to the power of m. Okay, same process, we're multiplying. So something that you can notice between the 4th, 5th and 6th index laws is that you multiply every single time. It all deals with multiplication. So let's have a go with the first question. We have x over y all to the power of 3. So we're going to take this 3 and put it there, and we're going to take this 3 and multiply it there. Okay, so we end up with x to the power of 3 divided by y to the power of 3. And in your answer, you actually don't need to leave the brackets anymore because now we don't have that 3 outside to the power of. The 3's already been multiplied in, so you can write your final answer like this. Okay? Now, again, you need to imagine that here we have imaginary 1s on top of the x, so it's x to the power of 1, y to the power of 1. That is why this works. It's not a matter of just getting whatever number is out there and just placing it on top. It is actually being multiplied by the imaginary 1 that's up here. So I'll show you with this example. This can also be written like this. P to the power of 1 and Q to the power of 1 because there's only one P and there's only one Q. This 1P and 1Q that is being divided is all being put to the power of 2.5. So what I'm going to do is multiply this 2.5 there, multiply this 2.5 here, and I get this. So I don't actually need my brackets, just ignore that. We've got P to the power of 1 times the 2.5, okay, and then we are dividing that by Q to the power of 1 times the 2.5 that's outside the brackets. Okay, then we can get an answer for what is up top at the powers of each variable. Anything times 1 is the other number, so you already know the answer should be 2.5. So our overall answer is P 2.5 divided by Q 2.5. Okay, so it's the exact same thing that we did here, except I'm just making you realize and understand yet again that there are imaginary 1s on top of singular numbers and letters. Okay, so let's go on to the third question. This time it's a little bit different because there are already other numbers apart from imaginary 1s on top of each letter or variable. Okay, but it's the exact same thing. You're going to take this 4 that's to the power of everything inside the bracket and you're going to multiply it to the top and you're going to multiply it to the bottom. So you get a to the power of 2 times 4 divided by b to the power of 5 times 4. Now let's get answers for these. We have A, 2 times 4 is 8. Divide by B, 5 times 4 is 20. And there's our final answer. Now, if you, like I've said, don't feel comfortable doing the multiplication in your head, you can use your calculator. You don't need to input these numbers in as a power, you just do it as a normal multiplication. So if you wanted to find out what 2 times 4 is, you just do 2 times 4 like normal in your calculator and press equals, so you obviously get 8. And then 5 times 4 will give you 20. Okay? All right, next one. This one is one step harder yet again. Now we've got the exact same situation as here, but we've got numbers in front of our letters, okay? So in other words, we have coefficients in front of our variables, okay? So what do? Well, the exact same thing, okay? What did I tell you is imaginary on top of a number and a letter if it's just by itself and it's singular? A number 1. So this is actually the same as 2 to the power of 1. And this is the same as 3 to the power of 1. Okay? You can actually break this up if it's easier for you and write it like this. What imaginary sign is in between two things with no gaps? A times. And I can write this like this. So now it's easier to see where I need to multiply everything. Okay, so this 6 is being multiplied to here. It's being multiplied to here. And then it's being multiplied to here and here as well. It's being multiplied to everything, including these coefficients or numbers. Okay, everything must be multiplied by the 6 to its power. Okay, so then we get 2 to the 1 times 6 times C to the 3 times 6. That's our top line done, or our numerator. Now let's go to the bottom, or the denominator. 3 to the power of 1 times 6 times d to the power of 5 times 6. Okay. So let's tidy this up. 2 to the power of 1 times 6 is just 6, so 2 to the power of 6 times 3 times 6 is 18, so c to the 18. Divided by 3 to the power of 6 times d to the power of 30. Help if I write the d first. Okay, there we go. Okay. Now, we can't do anything here and we can't do anything there, but we can get actual values for what 2 to the power of 6 is and what 3 to the power of 6 is. Now, if we write both of these in expanded form, because remember this is index form, that is index form. We learnt that in our first lesson back at school. If I write these two in expanded form, this is what I get. And I'll actually write it in a different coloured pen. This is the same as 2 times 2 times 2 times 2 times 2 times 2. Okay, this is 2 multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. And this, like you may have guessed, is 3 multiplied by itself 6 times. 3 times 3 times 3 times 3 times 3 times 3. But, so we don't have to work this out in our head, that's what our calculators are for. Let me show you how to input it. I showed you last video, but just in case you forgot. If I do this one first, I write in the 2. And on my calculator, it's an X with a white square. So I'll press that button and I put in 6. So you can see that looks exactly the same. My answer is 64. And you know that we can tidy this up by writing our answer without the multiplication sign in between. So I can go ahead and just write 64C18. Like so. Just move my page up a bit. Okay, let's do this one. Again, I put in my number 3 to the power of button. Mine looks like this. And then I put a 6 equals, and that equals 729. And again, I don't need to put my time sign here because 2 things next to each other with no gaps means imaginary time sign anyway. So I can just go ahead and write d to the power of 30 straight away. Like so. Okay, so what I've done is this in expanded form equals 64, and you can work it out by using your calculator. Okay, this in expanded form equals this. Well, sorry, the expanded form is here, but the actual answer is here and here. Okay, and you can calculate both of those by using your calculator like I did. That is how I ended up with these numbers. Okay, and this is my final answer. So I'll just go back up. You can pause the page here to actually write down the law. And then, oh, it's just going to cut out. So I'll leave it here, pause and screenshot this for question 1 and 2. And then you can pause and screenshot this for question 3 and 4.